Hello! Today, I'm going to show you how the PowerShell script monitors and reports issues related to CPU, memory, and disk usage, as well as attempts to fix them when thresholds are crossed by freeing memory, cleaning up disk space, or terminating high CPU processes. First, I have defined the thresholds for the 3 monitored items. Next, I specify the location of the log file so that the script can create a file and log its activities. In this case, it is saved on the desktop. The log action function, which is responsible for keeping a record of everything that happens in the script. Whenever the script takes an action or checks a system parameter, it logs the event with a timestamp in the log file. This is the check CPU function, which monitors CPU usage by querying the processor total processor time counter. If usage exceeds the threshold, it identifies the most resource-intensive process and uses the stop process CMD LED to forcefully terminate it, helping to restore performance. This is the check memory function, which monitors memory usage by checking the available memory in megabytes. It calculates the percentage of memory used, and if it exceeds 80%, the function clears the system's temporary files by calling the clear memory cache function to free up memory and improve performance. This is the clear memory cache function, which deletes temporary files to free up memory when usage is high. It retrieves all items from the system's temporary folder and attempts to remove them. The function logs the number of files deleted and any errors encountered, helping to optimize system memory and performance. This is the check disk space function, which monitors the disk usage of the C drive by retrieving information from the Windows Management Instrumentation WMI. It calculates the total used and free space in gigabytes, as well as the free space percentage. If the free space percentage falls below 20%, the function calls clear memory cache to delete temporary files, thereby freeing up disk space and helping to maintain system performance. It also logs the disk space details for reference. This is the run system health check function, which sequentially calls the check CPU, check memory, and check disk space functions to monitor system health. The infinite loop surrounding this function runs the health checks every 600 seconds 10 minutes, allowing for continuous monitoring while using start sleep to prevent resource overload. This setup ensures timely interventions if any thresholds are exceeded. Now, to check if the script is reading the system information correctly, I will run the PowerShell script. I will end the script using ctrl-C as it runs in an infinite loop. Now, I will open the log file to ensure it is working as expected. As you can see, the data is being read by the script and transferred to the log, which demonstrates that the script is successfully performing the basic tasks of creating the log file and logging the measured parameters. Now, to check if the remedial actions can be carried out by the system check script, I have created another script, high CPU, which continuously calculates the square root of a number without displaying or using the result. Since it runs in an infinite loop, it will constantly consume CPU resources, leading to high CPU usage. Now to check, I first run the high CPU script and open the activity monitor to see if the CPU usage has increased. I have also modified the threshold in the system check script, setting it to 50% based on data from previous runs and the percentage of CPU usage observed in the activity monitor. Then, I run the system check script. As I started the system check script, you can see that the high CPU consuming process in the activity monitor has been terminated. Now, after pressing ctrl-C to stop the script, I can view the log file. It shows that the CPU load was 51.57%, which is higher than the threshold set. The script detected this and took remedial action by sending a kill signal to the process. The name of the process, along with its process ID, has been logged in the log file. And then remaining parameters are checked, which are within the threshold, therefore no remedial action. Now, to check if the system check script can carry out remedial actions for high memory usage, I have created another script called high memory. This script simulates high memory usage by creating an infinite loop that continuously appends 1 megabyte byte arrays to an array, causing memory consumption to grow steadily. It also creates 100 small temporary text files in the temp folder to verify if the deletion is accurate, but the primary memory load comes from the byte arrays. First, I run the high memory script and wait for the memory usage to increase. I have slightly modified the thresholds, setting the CPU usage back to 80% so that the process won't be killed, and setting the memory usage threshold to 50%. As seen in the activity monitor, the memory usage has risen to approximately 76%, well above the 50% threshold. I then run the system check script, ensuring that the CPU threshold has not been crossed yet by checking the activity monitor. Since it took a few seconds for the CPU usage to increase, we can assume that the 100 temporary files in the temp folder were deleted due to the high memory usage before the process was killed. Now, to check this, I press CTRL-C and look at the log files. As can be seen in the log file, the CPU usage is 63.08%, which is below the 80% threshold, so no remedial action is taken. However, the memory usage is at 92.59%, exceeding the 50% threshold, triggering remedial action. The script calls the clear memory cache function, which deletes the files in the temp folder. This action is logged in the log file, which includes the path to the temp folder and the number of files deleted. Some files could not be deleted as they were part of currently running operations. After this, the remaining processes are conducted. As CTRL-C was pressed, only one run occurred. Now, to check for low disk space, I slightly modified the code to ensure that the data from the system is represented more clearly. Then I perform a test run to check the system's disk statistics. As can be seen in the log file, the information is now more detailed. Now, to check if the system check script can perform remedial action if there is low disk space. In order to create a scenario, another script is written called lowdisk, which generates 10 large binary files in the system's temporary folder, with each file sized for 1000 megabytes. It creates byte arrays matching the file size, writes them to files, and logs the creation process to the console. After all 10 files are written, I wait for the system usage statistics to stabilize in the activity monitor, as I don't want the files to be deleted due to threshold crossing in other processes. Then I run the system check script, wait for a few seconds and end it using CTRL-C. I then open the log file to check if remediation has been conducted. As noted in the log, the disk space is found to be low at 11.81%, which is below the 20% threshold, thus calling the clear memory cache function for remediation. The remediation process is logged, and it shows that 10 files were deleted, which is accurate in this case. To verify that the low disk space is actually affecting the C drive, I repeat the process and use the GUI elements for confirmation. Thank you for watching. The PowerShell scripts have been uploaded as text files. Thank you.